Hey guys, I'm going to do a couple of one example using 3 different techniques or 4 that we did in class. First of all, this is example 3 from the classwork and homework that you need to finish. The left endpoint requires us to start at the left endpoint, which is in this case -3. All we're going to do is go to the actual function value for -3, which is 1.5. And at this point, we're going to create a rectangle moving inward because we want the area inside, right? It makes no sense to move to the left because there's nothing there. So I'm going to go ahead and calculate the area of this rectangle. We know that the width is 1. So remember that the area of a rectangle is length or height times width. So in this case we have a width of 1 times a height of 1.5 because at -3 the height was 1.5. Or the height or the y value. So next we're going to continue and take a look at this endpoint. We're going to trace it all the way back to the next function value, which is, since we're looking at -2, it should be at 4, right? We're going to create another rectangle. And we're going to be calculating the area of this rectangle. Again, the width is 1. And the height is 4. I'm actually going to multiply this right away. Next, we're going to take this endpoint and trace it to the next function value, which at -1 should be 5.5. So again, I have a width of 1 and a height of 5.5. And I think times 1 is just 5.5. It's the same thing, so it's 5.5. We're going to repeat the process. This point, we have 1 times 6. And my next function value is over here. So I'm going to repeat the process. So I'm going to have 5 times 5.5. I use 5 rectangles. 1, 2, 3, 4, 5. So I have 5 different areas, right? So when you really think about it, the sum, this is sigma in the Greek alphabet, the sum of all my heights, I'm going to call the height the function value because that's all it is, right? Of all my f of x's times, I'm going to call this the width. I'm going to call this the width for now. I'll give it the proper name later, but all my function values times all my widths gave me what? What's this? 11 plus 10 is 21 is 22.5. Oh, that's not right. 22.5. If I did the math correctly. So it's 11, 15, 21, 22.5. Because they're going to kick me out of school. We need to finish with the right endpoint, and we're going to keep it to 5 rectangles just because I'm short on time. I wanted to show you that the more rectangles you get, the more accurate of an approximation you'll get, but I guess you can do that as homework. So do 5 rectangles. We're going to repeat the same process, and I'm actually going to do this really quick. X, Y, -3, -2, -1, 0, 2, 5.5. That's actually 4. This is 4, 5.5, 5.5, 6, and 1.5. Sorry about that. So we want to repeat the process of the left endpoint technique, but using the right end. So we're going to go ahead and start at the right endpoint, create a rectangle inward. We know that the width is 1, and the height at 2 is 4, so it's 1 times 4. We're going to go from here to the next point value at 1. The next function value at 1 is 5.5, so I'm going to have 1 times 5.5. Over here I'm going to move up to the next function value, which is 6. Create my rectangle, and I'm going to have 1 times 6. It's actually 6. Next function value here is 5.5 again. So I'm going to have 1 times 5.5. And over here, repeating the same process, I'm going to have 1. This should have been multiplications, guys. I'm sorry, I'm in a big rush. Repeating that, it's going to be 4 again, because that's the height I gave it, right? So if we add all of these up, what am I going to get? 11 plus 8 is 19, 25. So again, the sigma of all my function values times my width. Notice that this is the height, right? The function value is the height times the width is the area. So the sum of all my areas is 25, which is a different number than we got when we used the left endpoint. So I'm going to move on to the next video quickly. Okay guys, quickly I'm going to go on with the next technique, which was using inscribed rectangles. The concept of something that's inscribed comes from geometry. This is an example of an inscribed rectangle inside of a circle. It means to be inside, and if you look at these 3 letters, that means that it's inside of something. So we want the rectangles here to be inside of the curve, not crossing the curve out to the outside. For instance, I'm going to start over here, and I want rectangles that don't come out. So at -3, my function value is 1.5. So I have a width of 1 times 1.5. We're going to continue over here, and I'm going to go to my next function value, which is at -2, 4. And I want to stay inside the curve. Okay, so I'm actually going to go ahead and finish these. At -1 is 5.5. If I go to 6, then I'm going to come out, so I don't want to do that. I'm going to stay in here. And what I mean is, if I were to continue over here, I would have gone out, but I don't want to do that. So next, if I go to this function value, I'm going to come out of the curve, and I don't want to do that, so I want to stay inside. So again, we have 1 times 5.5, another 1 times 5.5. You could have done 2 times 5.5. And you have a 1 times a 4. Okay, so if we add these areas, I'm going to get these 2 becoming 11. This is actually 4 and 4. So that the sigma, or the sum, of all my function values times their widths is 20.5 in this case. Okay, if you have any questions, please shoot me a message. Okay guys, finally I'm going to use the midpoint technique. This is the one that gets a little bit more involved. I'm going to use the same function, -3, 1.5, -2, 4. So it's going to have a curve that looks like this, and this is not the most precise curve, but this is assuming that your curve was correct. So the midpoint, and we're going to use 5 rectangles again. So all this is saying is that I'm going to use the midpoint of each unit. For example, I'm going to have, these are going to be my widths, right? Each width is going to be a unit. And what I'm going to use in essence is the midpoint of each width, of each little base of the rectangle. So over here, if this is my base, this is the midpoint of my base. So I'm going to trace it up to its function value. So it's going to be somewhere over here. And note that we can actually find the exact values here. And I'm going to do things out of order, out of the order that I've been doing it in a minute. And I'm going to do the rectangles first. This is somewhere over here, actually. That was very poorly done, I'm sorry. So if I have this over here, same thing over here. And these are just mere approximations. Over here, I'm going to trace it again. And since it's symmetric, it's probably going to look very similar. Okay, and what I'm going to do to actually find those heights, because notice that the heights haven't changed. I'm going to have 5 rectangles of, the widths haven't changed. So I'm going to have 5 rectangles of width 1. So where is this midpoint? It is exactly between -2 and -3. So it's a -2.5. Same thing with this midpoint. It's exactly between -1 and -2, so it's a -1.5. This is a -0.5. This is at 0.5. And the next one is at 1.5. That's an ugly 5. So what I'm going to do next is calculate those function values. Completed the table of values, and we found the y values, which are going to give us the heights. So to calculate these areas, we're going to multiply the function values times our widths. We have the widths, which are 1, and now we calculated the function values. So my first one is going to be 1 times the function value at -2.5, which is 2.875. And then the next one is going to be -1.5, so it's 4.875, and it's going to be symmetric to this one over here because these two are the same height. So I'm going to have 2 of those. And here we're going to have the function values at -0.5 and 0.5 respectively, which are 5.875. And I'm going to trust you to do the math with those. Remember, you want to add those function values. So take a minute to do that, please. So I did it myself. So if you did this correctly, you should have gotten 24.375. So keep in mind that we keep getting different results, and the reason is because we keep using different techniques and we are approximating something, so our answer is not going to be exact. The whole purpose of this is for you to kind of determine which technique gives you a more accurate approximation.